Okay, so now the last thing we're gonna talk about is inverse of functions. Okay, so if I gave y'all f of x equals 3x plus 1, the inverse, I'm going to ask you to find the inverse. It's often noted as this, f raised to the negative 1 of x. Does anybody remember how to find the inverse of a function? I bet my two college algebra. My college algebra students from last year.
Still don't remember.
No buttons on there.
Actually, no, I think it's
That's
actually.
reciprocal.
What did she
Inverse and reciprocal often get confused.
Oh, yeah.
Do what?
You do like 1/3 x, and then
Good guess though.
Oh, I did this once upon a time.
once upon a time.
Anybody know it? Anybody remember it?
It looks familiar.
It looks familiar.
Once you tell
Maybe.
me, it's like
I might. Don't you just make it? Don't you just make it
I keep thinking of like
Negative?
signing to sign.
something? I don't remember. Oh yeah. You like make it 3y plus.
All right. So I don't see a y up here. What's happening with inverse? Let me show y'all what's happening. Say you've got this function, and this is the y-axis, and that is the x-axis, right? So with inverse, you actually rotate the axes like 90 degrees. So this now rotates this way, so that I'm going to change colors. I'm going to make this blue. This is now the y, and this is the x. So if I rotated, the x is now up here, the y is here. And when I rotate this, it looks like that. Okay? So, the y becomes x, the x becomes y, and you solve for the new y, which we then always label as that at the end. I don't see a y up here. F of x is y, so y becomes x, x becomes y. How would I solve for this new y? X, what am I going to do? Minus 1,
Divide by 3.
and then divide by 3. I don't want to leave it like that because I want to show that this is actually the inverse. So I have to write it like that.
Oh, come on, I was getting close.
Almost. You were almost. All right, so I want you to try these. I want you to find the inverse of No, you do not. That's only if I'm asking for domain. We will do domain and range of the inverses. But, we'll talk about that tomorrow. There's the inverse of the first one. Watch it. Make sure you're okay. I cannot add the 1 over, why not? It's under the square root, so it has to be released. How would I release it from under the square root? Square both sides. So that's going to be x squared plus 1 divided by 2. And this one I'm going to write as g raised to the negative 1 of x. Guys, you're going to have to get good at inverses of every type of function. Cubes, and I'm going to go over 2 of the most difficult types right now. 2 of the harder types. The first one being a quadratic. Now your book gives a couple of ways to doing it. This one's tough, so if you've got f of x equals x squared minus 4x plus 7. Write it down. You do not want to put x, y squared minus 4y plus 7. You don't want to do that. Okay, it can be done. It's not as simple. So what you want to do when they're asking you to do the inverse of a quadratic is change this from standard form to vertex form by completing the square. We never get away from anything. We don't stay gone from it long. So that's one thing you have to remember. Somehow you've got to commit that to memory in your head, that if you're asking for the inverse of a quadratic, because you don't want this x equals y squared minus 4y plus 7 business here. That's going to be a nightmare to try to work. So the easiest thing to do, at least in my opinion, the easiest thing to do is let's set it up to complete the square. Are we remembering? That's why we got to loop, is so that you don't forget things by next May. So when we complete the square, we expand, put our x terms in parentheses, put plus blank minus blank. Now what goes in the blank? B over 2 squared. My b is negative 4, divided by 2 is negative 2, squared is 4. Now, just as a reminder, if I factored out a 2 here, what would I put here? Negative 8. Okay, so just remember, if you factor something out, you got to be careful. So now, how do I write that in vertex form? X minus, no, not x squared, just x minus 2 squared. There's where my square goes. Plus 3. So this, I haven't even done the inverse yet. I had to complete the square first. So not a whole new lesson on that, just a little reminder. So now to complete the square, now to do inverse. Y becomes x becomes y. What would I do here? Not square root just yet. Subtract 3. And then what? No, I don't want to full this out. I'm going to treat it, and I'm going to square root both sides to release that. Okay, so that's going to be the square root of x minus 3 equals y minus 2. Because if I fold it out, I'm going to get that awful y squared and y again. Now what would I do to get the y by itself? Add 2. So your inverse would be 2 plus the square root of x minus 3. Okay. So let me give you one to try right now. I want you to find the inverse of that. Alright, so I'm separating these out. Leave my x terms, put plus blank, close parentheses, minus blank, plus 9. So my b is negative 10 divided by 2 is negative 5, squared is 25, subtract the 25. So x minus 5 squared minus 16, is that looking right? That's only the completed square form. That's not the inverse. So y becomes x becomes y. So I'm going to add the 16 first. Take the square root. Add the 5. Now guys, I don't care where you add the 5, but that 5 better not look like it's under that radical. Okay? Better not. You can put it out in front, you can put it way behind. It just cannot be under the radical. So you can put it out here, or you can put it out here. Okay. Now the next kind looks something like this. the last I'm going to go over today. They're fractions, rational equations. So they want me to find the inverse. Y becomes X. Sorry, that should have been a X. X's become Y. Not a quadratic, so I don't do a complete the square. Do I have a denominator? How do you always and forever get rid of a denominator? Multiply. So, everybody watch me. I'm going to go over here right now. That's going to be X times Y minus 2 equals Y plus 2. Now, I'm going to go on and distribute this because I'm really interested in these Y's here. And this Y is stuck with this 2 until I distribute. Now look up here and make sure you can follow what I've done. Just don't mindlessly write. I want you to look up here and make sure that you're following me. Now, combine all Y terms, or maybe I should say all Y terms on one side, all non-Y terms on one side, because combine makes you sound like you can put them together. All Y terms on one side, non-Y terms on the other. So, tell me what my Y terms are. All right, and? Okay. Tell me what all my non-Y terms are. Negative 2x and 2. So I want to get the green ones on one side and I want to get the blue ones. Does it matter which way I move it? Now, I will tell you this. If I ever put an answer up on the board and all your signs are opposite, I'm not talking about 2 out of 3 or 3 out of 4. If all of them are opposite, it's equivalent. It just means that you moved all your stuff to the other opposite side than I did. So I'm going to subtract this Y and move it over here. I'm going to add the 2x and move it over here. So now I have xy minus y equals 2 plus 2x. Now, the last thing you do is to factor out y instead of an f. Factor out a y. Okay, how will I solve for y now? Just divide by. So that, everybody, is the inverse of a rational equation. That means there's x's in the top and the bottom, denominator and numerator. Okay, so let's try this one. Give me the inverse of that. So I'll work on that real quick. Okay, so we changed the y to x and the x's to y's. Get rid of my denominator by multiplying. Distribute. Get all my y terms together. Now again, this is where we may differ. You could have done notice all my signs are opposite. So either way, either one of those are okay. Factor out a y. In this case, now I get to divide by the x minus 1. In this case, 1 minus x. Notice all my signs are opposite. So if we're ever grading anything and all the signs are opposite, regardless of what we're doing, if all the signs are opposite, it's equivalent. Okay, either one of those are perfectly okay. How are we? Okay, so tomorrow's lesson, what we're going to do is we're going to pick up and we're going to practice more inverses like these. We're going to go over natural domain and range and do some solving with inverses in it. So, all right, so we're going to call this